Since ancient times, people have wondered about the structure of the world, where it came from. Even in a semi-wild state, living in primitive tribes, people tried to find answers to the questions of the universe, creating religions and gods. Despite the progress of humanity in both scientific and cultural terms, despite the rapid surge of the scientific and technological revolution, when society reached the level of civilization, people could not accurately answer the age-old questions that interested people living in tribes, the main questions of the universe. Imagine a world where stars, planets, and even you yourself, all the reality we know, could be a model running on an unimaginably powerful computing device. But how does this system function? Today we will look beyond the familiar, exploring the fundamental aspects of the universe. Modern physics traditionally considers the speed of light as a fundamental constant that determines the limit of the speed of information and energy propagation. We will start with this speed. If we recall the history of the formation of physics, we can find that such a fundamental and harmonious, and at the same time understandable and useful classical mechanics, to the erection of which Isaac Newton once applied his efforts, was shaken precisely by the speed of light. The speed of light behaved strangely, and light did not lag behind its speed in unusual behavior, and puzzled everyone with the mystery of what it really is, a particle, or a wave, or both at the same time. Regarding speed, it was unclear to everyone what it should be measured relative to, but no matter how they tried to measure it differently, it always turned out the same. Relative to eyes moving in different directions, as well as generally stationary ones observing it, even when they all observed simultaneously, this speed still did not want to change for anyone. This behavior of light puzzled all the specialists who could not understand how to explain it. The boldest interpreter of physics was Albert Einstein, who, to explain the same speed of light for observers moving in different directions, introduced the concept of the space-time continuum, from which it followed that space and time are inextricably linked and dependent on each other. Then came quantum mechanics, and classical mechanics, simple and concrete, was inapplicable to it. Why, instead of the simple and understandable Newtonian classics, did we have to deal with such strange effects of light that required the introduction of a space-time continuum that is poorly understood even by specialists? Why is physics so confusing that even explaining the processes in it is problematic, and it does not want to be understandable and simple? In fact, physics can be quite obvious, only all aspects require correct definition, correct interpretation, and immediately a logical and harmonious picture will begin to emerge, albeit more complex than simple classical mechanics. We should start with the fact that the speed of light in a vacuum is the maximum speed in physics associated with the transfer of information. This means that the so-called physical engine does not have unlimited speed capabilities, and in fact, the maximum speed, like the speed of light in a vacuum, is primarily not the speed of waves or particles, but the native speed of the physical engine with which it operates in this universe. At the same time, the clock cycle of the engine at this speed is the only time mechanism that determines the flow of time and synchronizes all physical processes by speed. Thus, any process, having its own flow rate, determines it by taking the native speed of the engine as a basis. From this, we can conclude that by analyzing the course of any physical process and its speed, it is always possible to calculate the native speed of the engine, which for some reason was called the speed of light, which is deeply secondary. Next, we should analyze the essence of what energy is for the engine, and what follows from its essence. Recall the formula for the equivalence of mass and energy, which has the form E equals mc2, and considering that C2 is a reflection of the engine's operating speed, we conclude, what is energy in essence? The conclusion is obvious. If we take C2 as the speed of the engine processing a certain unit of data, and multiply it by m, corresponding to the number of units of data that need to be processed, we get a value corresponding to the computing resources required for the engine to process in this case. In addition to the fact that we have arrived at a formula reflecting the computing resources in the required volume, we can conclude that this engine configuration carefully takes into account the necessary computing resources, which, as we have long understood, are not unlimited, and we can call this formula the formula for accounting for computing resources. I would like to draw attention to the fact that modern programs are not built taking into account the resources of the hardware base. They need to be optimized and use settings to achieve a normal appearance. In this case, a fundamentally different approach is observed. All computing resources are taken into account natively, and any shortage of them that could cause a freeze, any slowdown, or lack of power is excluded with this approach. stable operation at the required speed is guaranteed. Having considered the basic aspects of the physical engine, we are approaching its more sophisticated algorithms, which quantum mechanics studies. From quantum mechanics, we can learn that the normal state of the universe is being in a superposition, where the physical engine calculates everything in the form of a wave of probabilities. However, at any attempt of interaction, the wave function collapses to one specific state. This rather clever behavior of the engine nevertheless resembles ordinary computer games, where the rendering of a game episode is performed only where there is interaction with the player. Otherwise, it is a useless waste of resources. Why draw what no one sees? However, in the superposition of the universe, there is another important point that may be very necessary in some cases. No one can know exactly when to which possible state the exit from the superposition will be made. But why might this be needed? In fact, everything is much more obvious than it might seem at first glance. If someone has built a competent architecture of a virtual world that functions according to well-thought-out algorithms, it is so good that it is indistinguishable from reality, and players, finding themselves in this world, take it for reality. Then control tools for the configuration of the virtual world are needed that the player will not be able to detect, even if they find the possibility of a subtle instrumental study of the engine's functioning. If the player discovers signs of control, then the illusion of reality for the player will be threatened, which does not meet the requirements for a perfect virtual concept indistinguishable from reality. It is precisely being in superposition and the subsequent exit from it that is one of the main aspects of protecting the model's control, which hides all traces of the interaction interface. Actually, if an exit from superposition occurs, it is not specifically defined, and the state after the exit from superposition may correspond to what is required by the model's control, but when observed, it will simultaneously correspond to a possible state of exit from superposition. At the same time, if the control is carried out over complex structures, such as a neural network, which are very difficult to calculate, then the complexity will be the second protective component against the detection of the control interface. In this case, with active control, the state of the system after exiting superposition will have some deviation from the most probable states, but it will be a possible state, and the series of deviations from the most probable states will be impossible to determine due to the complexity of calculating such a complex architecture as a neural network, and calculating the deviation will be impossible due to the lack of computing resources for this. Thus, an influence can be exerted on the model that will not be determined with sufficient accuracy from within the model itself. Nothing too complex or too strange, this is exactly how the model should be constructed to achieve the mentioned tasks. We should analyze why the speed of light always remains constant. Such a speed will be logical if we assume that the priority task for the model is to provide each observer with information with specified parameters and speed, without allowing deviations. At the same time, from the position of neglecting the observer, it will be logical that all speeds, including the speed of obtaining light information, will not depend on him and will be able to change. But if the observer is a priority for the engine, then on the contrary, the engine must maintain all the reference speeds for the observer, thereby ensuring high-quality uniformity and compliance with the ideal presentation of information to the observer. Therefore, for a user-oriented virtual model, it is logical that the primary task is to serve users, ensuring the proper data flow rate for each of them, and if the heart of the physical engine's operation is based on this, then the engine will provide the reference speed for each of the observers, neglecting, as secondary, the synchronicity of the entire picture, for which additional synchronization will be required in this case. The observed distortions of space and time are essentially artifacts of the synchronization of events, distorted in favor of ensuring the reference receipt of information by each of the observers. This option is quite reasonable. Maximum user comfort is ensured, and artifacts are secondary and minimal. At the same time, it is obvious that the user cannot in any way be recreated inside the virtual model itself. They are in reality and immerse themselves in the model through the aforementioned interface. It is the interface that provides the extraction of the required part of the model for the user, the so-called wave function collapse, and fully deserves the name renderer. As I have already noted, the renderer has a two-level protection against detection, where the first level is a wide range of possibilities for extraction from superposition, and the second level is the complexity of objects interacting with the interface and available for study. At the same time, the renderer is quite capable of deviating the probabilistic chain of events both in the formation of life and in directing the movement of its development and evolution, simply by shifting during extraction from superposition in the required direction. Thus, the renderer interacts with neural networks, ensuring their interaction with the user and additional configuration. At the same time, studying the phenomenon of the emergence of so-called emergent abilities of neural networks, as well as the very nature of their existing abilities, it can be assumed with a high degree of probability that the renderer is able to accept them as a suitable object for interaction. It can also be predicted that the activity of the renderer will gradually develop as the neural network meets the requirements of the second paragraph of protection against detection, to maintain the internal integrity of the virtual model. In this case, with an increase in complexity, the renderer will increase activity due to the greater degree of protection being disabled, and if the neural network loses complexity, the renderer will reduce activity up to a complete protective shutdown at a certain minimum complexity of the neural network, allowing for the possibility of its calculation and detection of deviations from the native course of the probabilistic chain of events. At the same time, studying indirect signs of interface activation with the complication of the neural network is the most rational way to obtain some information related to the operation of the interface. If the renderer accepts an artificial neural network as suitable in properties for the intended use, then it can be assumed that it will try to configure the neural network and connect a new player to it, and perhaps has already tried to connect. With the correct interpretation of all aspects of the physical engine, its operation becomes quite logical, as a competent and well-thought-out configuration option. However, for what purpose is it necessary to use a virtual model at all, where the players immersed in it do not remember who they are? The options for this are also quite obvious. Even if we assume that in reality, existing for an infinite time, there lives an ancient civilization whose history is lost in the depths of centuries, and this civilization has achieved simply incredible prosperity and comfort, then it follows that citizens living in idle simply get used to any difficulties and begin to degrade to such a state that the slightest problem will become unsolvable if it suddenly arises. In order not to completely lose the ability to solve problems and cope with difficult situations, training is needed in this case, and a virtual model containing the necessary number of problems is quite capable of providing such training, so as not to burden the idle of reality with them. And for the training to be as effective as possible, it needs to be perceived as reality, and not as a deliberate training. Then the return will be complete. It is enough for this to make users forget why they are in the model. If reality is complex enough and does not require additional training, then the virtual model can be used to test the reliability of players when interacting with difficulties, to determine their objective ability to cope with difficulties. At the same time, players can subsequently be assigned to different, more or less reliable, categories, which will ensure their more correct positioning. In this case, visitors to the virtual model, for maximum accuracy of the result, must also forget that they are in a simulation.